try to solve it through solver. There are IBM Simplex, there are different softwares which do the same thing, right? Linear optimization or like kind of integer optimization. Other way is to convert that. So in the backend, the simulation software will convert that into a simulation algorithm and run it for us. So we need not have to worry about the formulas or the equations. What we have to worry about that, what are the constraints or the parameters we have to give. Software is going to work for us and calculate or carry out all those equations or write down all the equations. We need not worry about which kind of equation we have to write, right? So those are the two approaches. So we are kind of basically two methods, like I said, analytical methods, complex simplex, and dynamic simulation methods. What we are looking into in through these softwares or this tool is kind of creating different simulations and trying to understand how supply chain works and how to optimize a supply chain, right? So under those analytical method or simulation, we'll learn about something called greenfield analysis, GFA. Then, like I said, network optimization. Then later on, right, towards the end of our sessions, we'll discuss something called risk analysis, right? So there are different type of risks. COVID happened. That is one of the biggest challenge or risk which has happened. Can I build a what if scenario? Can I build, or right now when that risk or issue has happened, can I do an analysis saying that okay, how much loss my company is going to make in next 6 months if lockdown happens in few cities, or if let's say there is a transportation strike due to certain kind of political problems, how much loss my company will incur, right? Because see, as a supply chain, these things you have to like I think few months back there was a big problem when a ship got stuck in Suez Canal. No other shipment could move through for I think few weeks. So in those kind of channels, yes, like in those kind of scenarios, you have to build for a future plan, right? If shipment doesn't move for next 7 days, what kind of loss my company will make? If I go by the alternate route, how much money I have to pay, how much additional cost I have to incur, right? So those kind of what if and visualization will carry out towards the end of our sessions, right? But the end goal is kind of enhanced business decisions in terms of maximizing profit and reduction of cost, right? So these are the few things what we are going to cover throughout the class. Next, whatever 5 or 6 classes, including today's class. Facility location planning. Let's say the first what we are going to try today is the greenfield analysis. So I have customer, I know where are my distributors or dealers, 6 or 8 distributors I know who are going to buy or who will have regular demand of electric vehicles. So based on that, where I should put my distribution center, where I should put my warehouse, right? So that is the first decision I have to take. How many warehouses I should put, and where should I put those warehouses, right? So network optimization will take care of the how many warehouses, right? How many warehouses, how many factories. Center of gravity method of single or multiple locations will talk about where you have to put that, right? So those are the two scenarios. How many, first I have to decide where to put it, which locations I should put my distribution center and warehouses. Other factor or other thing which I have to consider is how many warehouses or how many distribution centers. Then capacity planning of distribution centers. What should be the capacity of those warehouses? How many things they can, like, because we have to think of inventory also. How many products they can carry and they can transport from a single warehouse. Will it be a small warehouse or a big warehouse or a mega warehouse, right? So think about companies like Amazon when they are deciding. So each state they can put smaller warehouses, multiple smaller warehouses, or they'll plan for a one big warehouse in each state, right? 28 or 29 states, they can put one big warehouses in each state, or for each state they can put multiple 4 or 5 smaller warehouses. So how to decide, right? Then inventory control policies and ordering rules. So whenever a demand is coming from the customer, so in all the simulation, when we are talking about customers, we are not talking about the individual customers like you and me, right? So for the supply chain, we are considering customers as our distributors or dealers, because the demand, actually customer is coming to them buying products for them, right? But for a company, they become my, though they are my channel partners, demand is coming from my like kind of distributors or dealers for the supply chain model which you are creating. So they are the customers, right? Then sourcing policies, single or multiple sourcing. The same product or components which I'm purchasing, how many suppliers I'm employing for those purchases, right? Do I have a backup in case certain supply chain disruption happens? Do I have a backup, right? So those things also we'll look into. Then transportation policies. Full truckload is FTL, less than truckload, less than load is LTL, right? So what kind of transportation policies for which kind of warehouses for which kind of customers, right? So if you see one by one, our complexities are increasing, right? Batching in transportation, production and sales, right? So if you remember in the production planning in our second analytics, what we discussed, production analytics. So there might be back order, there might be issues with your production. So anytime a production happens, most of the times it is a batch production. So once you have a demand for 400 or 500 units of production, then at a single point of time, one or two shifts, they complete the production batch, then transport it. Then there might be, in some cases, idle period, right? Then again the production starts, right? So how to batch that production, the production cycle, then similarly when to send those to the warehouses or to the customers, right? Then when I talk about risk analysis, I was talking about bullwhip effect and ripple effect. Ripple effect, the same example what I just discussed, something like a COVID. COVID happened 2 years or 3 years back. It started in China. Next 2 years, almost throughout world, 8 billion people suffered. Right, almost everyone. Nobody can say that okay, I have not gone through the problems caused by this pandemic. Right, same thing with any company you can think of, right? Though few companies did benefit from this kind of issues, right? Can anybody remind me what is the bullwhip effect that might have been covered in production and operation management? And that is a very basic concept in supply chain. What do you mean by bullwhip effect?
Sir, sometimes, suppose for example, at the retailer side, and the retailers are trying to do a forecast for their demand, and if there is error in their forecasting, then that error goes on accumulating to the manufacturing side. Like the supplier will also take that error and he will make some error in that, and so on. So the error will keep on increasing. So that is bullwhip effect.
So in terms of error, what Amak was telling about, it basically the positive side of the error. So basically we take a buffer. Think about a retailer. When order comes from the customer, he knows that okay, each week or each month there is a demand of 100 units. But when he is applying the estimate to the distribution center, he might add 20 or 30 units. So it goes to the distribution center and it shows that okay, 120 or 130 units, right? So that 20 actually he is taking it as a buffer, right? But there is no justification for that, right? It is only his own belief, which might be biased or which might be wrong. So in that case, what happens? The next person, which the distribution center, he also might add certain his own estimate or own buffer. So like that, if you see, by the time it reaches production from distribution center to the mega like forwarding agent or whoever is the like mega distribution center, from that to the production, right? So some buffer gets added. Actual demand might be 100, but when the production happens, it might be 180 or 160, right? Which is basically you are unnecessarily kind of producing 60 units, and for which you have to store and collect. There will be inventory cost, right? Like a bull, right? If like kind of I'm putting a whip, it start with a small kind of initiation, but it gets larger as it moves further towards the handle, right? So those are the risk analysis what we'll learn maybe after 4 or 5 classes once we cover all these four greenfield analysis. Okay, so one thing I have not written here. So that will be we'll be doing towards our end of Okay, so starting with greenfield analysis. So sometimes in the newspaper you'll be reading about, okay, there is a greenfield university, right? There is a university recently, I think I forgot its name. So when you talk about a greenfield refinery or greenfield production plant, so when you talk about greenfield, right, it is basically there are no other facilities available there, no other infrastructure available there. So think about that is a greenfield and some construction or some infrastructure are going to get developed, right? So in comparison to when you talk about brownfield, right, already some structure is available, right? Then you are expanding that. Let's say already a refinery is there, already a production plant is there. On that, you are making some modification, making some changes, right? So start a project based on prior work or to rebuild, engineer a product from existing one. So you have existing infrastructure which you are expanding. Let's say you have existing warehouse. You are want to add certain capacity. So that is a brownfield expansion, right? Any type of infrastructure when there is existing infrastructure and you are modifying that, right? Making some changes, increasing the capacity, right? So it becomes a brownfield expansion. Greenfield is starting from the scratch, right? Nothing is there. You are building a structure from scratch, right? From the very like airport, new road, hospital, warehouses, production plant, right? Anything we start from scratch, right? So that is the concept of greenfield. So for today's class and for your assignment, what we're going to do is a greenfield analysis. So what we are going to do are the steps, create a scenario, define supply chain structure parameter. So we'll start with a very simple one. So there are four things we are going to define. So location of our customers. So like I said, mention customers in whatever we are going to discuss in next few classes. Customers for us in the supply chain will mean the distributors or dealers, right? Because the demand will be coming from them. Then define the supply chains, customer demand, transportation, and sourcing policies. For today's class, only we'll define customer demand. Next class, when we carry out the simulation, we'll define the transportation and sourcing part. Parameterize the sites and policies, right? For each of those sites, like what kind of inventory policy, what kind of transportation policy, those things we have to define. Perform the greenfield analysis experiment to determine the best location for one or many warehouses, right? So our agenda for today is to, if I know my customers, if I know that, okay, I have 10 distributors or 5 distributors or 5 dealers, where I should put my warehouse, right? Create a KPI dashboard, collect statistics on supply chain performance. These things, if time permits today, we'll try to see that. Simulate the supply chain region with new greenfield locations and determine their impact, right? So we can do a scenario analysis. So I'll start with, let's say if I put one warehouse, where I should put that. If I have 10 customer locations and I have to put one warehouse, where I should put that. If I have to put two warehouses, where I should put those two warehouses. If I have to put three warehouses, where I should put those three warehouses. Then compare the cost. Will it be better for me to have one warehouse which will meet the demand of 10 customers, or two warehouses or three warehouses? So I'll build the three scenarios and compare them, right? So that we'll discuss and try to learn it together. So these are the few things which will be a part of our today's discussion. Customer, adding customer their locations, defining product, what kind of product. Again, like the exercise what I've given you today is for an electric vehicle, right? And there are four different models of that product: E20, 40, 60, 80, or something like that. Defining customer demand from each distributor or dealer, how frequently they are, whether they'll demand per week, per 15 days, or per month, or per quarter, that we need to define. Order interval and quantity, right? That's what I told. Demand type. Demand type is periodic, historic. I'll show you that how that is defined. Importing data from Microsoft Excel workbook, creating groups, creating new experiment. So this part, in case we do not get time, we'll cover in the next class. Basically, creating a simulation experiment. Okay, so let me stop the sharing here. And anybody has downloaded, open the any logistics.
Yes, sir.
Okay. Okay, so we'll start with a basic scenario. So if you click on this any logistics, this is the first screen which will come into picture. So keep the problem in our mind, right? So, and if time permits, I'll carry out the part of the exercise what I've given you, so that you have the idea how to approach. So think about the product. Let's say this Milky Moo or the milk supplier in Odisha, right? The company which is doing well, or Amul Taja, right? From the Amul, and we'll just take one product and try to see that, right? Let's say I know that okay, from these locations, from these districts in Odisha, out of 30 districts, let me take 10 districts, or let us start with a bigger example. Let's say certain product which I'm handicraft product, or certain product which I'm manufacturing from Odisha, right? And my demand are coming from four major metro cities, right? Now what I have to find out, where I should put my warehouse, right? So for that, at least a minimum three or four things are required. I need to know the location of the customers, I need to know the product demand, right? And I need to know that how many warehouses I should put, right? One, two, or multiple warehouses, right? So there are three different methods to define your customer locations. I'll show you all three of them. Okay. So let's start with the first one. We'll click new scenario. Okay. So I'll give today's date. So if you see here, if you just click on scenario type, so these are the four things. If you remember in the slide I was showing: greenfield analysis, simulation, network optimization, transportation optimization. We'll start with greenfield analysis, then we'll discuss hopefully next class simulation, then network optimization, and towards the end transportation optimization, right? Under simulation there are various risk experiment analysis which we'll do later on. So for today we'll start with a very basic one, greenfield analysis. So start date, so the start date end date is basically like what kind of, when this analysis or the calculation will be done, which period you are looking into, right? Mostly we'll be looking into future calculation, future period, future time frame. So let me just keep a time from, let's say, from 1st of March to 1st of May. March, April, okay, June. I'll take 3 month of period. March, April, May. Okay. Description again not required, but just let me put. Okay. So there is something called add scenario data. So that is the first method, or one way to define your customers. So when to use this, whenever you do not have idea about, let's say I'm starting a new product, right? And I do not have idea that okay, where my distributors or dealers will be, but I know that okay, customers will be from all throughout India. So almost all the locations, let's say it is a soft drink or something which is FMCG product, right? Demand can be from anywhere from India, right? So I'll go by, let's say I have done certain market research and I know that okay, per unit customer or per like kind of location, this is my demand. This is the product demand for different locations, right? So in those scenario, when I do not have the like kind of location data with me, right? Maybe for a new product or a new kind of thing which I'm launching. So I'll click on scenario data, right? So if you see there are three options, right? How the software will simulate or create customers for you, right? One customer per location with demand proportional to population density, right? So if I define which country, let's say I'm doing it this for India, I'll drag down, select India. So what happens depending upon how many locations I'm defining? Let's say I'm defining 10 locations, right? So depending upon population density, it will select. So the question is how it will decide the software population density. This kind of software will have a database of census data, right, which is publicly available for like whatever the last census. I think in 2011 it happened, right? So the last census data, it will be available, and for each country, I think for the other countries, whatever the latest data, it is available with the database of the software, right? From that, it will extract, and accordingly, it will define, okay, these are the major 10 population clusters, and it will put customers there, right? So one customer per location with demand proportional to population density. So it will assume that the demand for the product which we are going to simulate is based on the population density, right? Think about an FMCG product, right? If I want to estimate like the demand for a soft drink or atta, rice, dal, right? So that will be basically based on the population, depending upon if many kind of customers are there, demand will be obviously much more. Or I can define having equal demand, customers are distributed by population density, right? So all those locations I will have equal demand, and the customers, number of customers will be here. If you say only one customer, here what you see, number of customers will be dependent on the population density. Third one is having equal demand, customers are uniformly distributed by locations. Each location will have equal number of customers, let's say 100 customers, and having equal demand, let's say 10 kg or 5 kg rice per month, right? So like that, that also can be defined. So this is, like I said, this is one way to do it, not the best way. This is but the simplest way to define your customers. Then I'll come back, and when we do the actual greenfield analysis, I'll show you how to do it. So let's say I define 10, I have a new product to launch. Let's say it is a soft drink or a organic drink. So I choose the first option. I define 10 number of locations. Then order placement frequency, period days. So how frequently from the source, so again, like I said, customers mean dealers or distributors for me, right? How frequently the order comes to me, right? To the warehouse. So I'll say it is comes weekly basis, 7 days. Number of products and demand per citizen per period, right? That again I can define. If you go and search in Google, what is the soft drink consumption per customer, or what is the milk consumption per customer, right? You'll get some data. So I'll keep it simple, and I'll think it is one demand citizen per period. Number of products, again, I have kept it simple. But think about companies like ITC, any FMCG company. Number of products, it can be into 10,000 products or 5,000 of different products, or SKU, if I take 20,000 or 30,000 SKU, right? But again, I'm doing it starting with a very simple example. So I'll define 10 customer locations, order frequency, like when they're placing their order every week, one product only, and per customer, I have assumed only one unit of demand. Okay, per that 7 days, right? Then I put OK. So if you see automatically, it has created randomly, sorry, 10 locations, 10 locations in India. So which are the 10 locations? Mumbai, Delhi, Bangalore, Kolkata, Chennai, Ahmedabad, Pune, Surat, Kanpur. So these are the 10 top locations which it has selected, right? Like I said, this is one way to do it when I do not have idea about where my customers will come from. Then I'll show you other two ways where when I know that who are my customers and where are my distributors and dealers, right? So, so this is the first step. Customers are defined. Second thing, what I have to define is product, right? Let's say if the product is panic. So I'll say that okay, this organic drink comes in pieces, right? The packets, right? So that I define. So first customers were defined, then I product I define, then period anyhow start date is March to June, which I had selected, that has been selected. There is something called demand coefficient, which we are not kind of changing anything here. So think about demand coefficient is something when you have seasonality of product, right? Think about, let's say you are selling ice cream or raincoats or umbrellas or air conditioners, right? So out of those 4 quarters, different quarter, different seasons will have different demand coefficient. One is 100% demand. Whatever your forecast, you are assuming that it will go by that. But generally, what happens if I'm talking about air conditioners? Now the sales will pick up. Next 6 months, there will be huge, or the demand for whatever air conditioners will be high. Then once rainy season starts till the end of winter season, demand will be slightly down. So in that case, what you will say that okay, whatever your original forecast of demand, you will reduce that to some points, right? So in that time, demand coefficient might be zero point 0.7 or zero point 0.6, right? Or in some cases it might be higher also. Whatever you are forecasted, now you see that okay, suddenly let's say this Ukraine conflict is happening for certain product, people will start to store in their houses, right? The petrol, diesel, and all those things. In that case, demand coefficient might be little higher also, right? So one is the normal demand which you have forecasted. Less than that means you are thinking that there will be a seasonality effect which will reduce the demand, or if you increase that, that means you are estimating or you are assuming that that will be much more than whatever you have expected, right? So in our case, we'll keep it same because I'm just trying to show you an example. So customers, products, periods, now the demand part. So if you see, I have 10 customers. So for each customer, demand has been defined, right? So product, automatically organic tree, then demand type and parameters, right? Demand type is, if you see, there are three types of demand which is defined in this simulation tool. One is periodic demand with first occurrence, and historic demand. So when I talk about periodic demand, what I have defined here, right? What will be my parameters? So when does the first occurrence happens? First day, next day after interval, or random type within interval. So first day when I'm starting my simulation, or when my exercise is starting from March 1st to June 1st. So that is my time frame which I'm looking into. So first day means first March the demand will come, right? Or next day after interval, first 7 days it will take. Then from 8th March or 7th March the demand will come. A random time within interval within that first week, 1 to 7, because I've told the order frequency 7 days. So 7 days, any day, the demand might come, right? Depending upon how, like, what kind of agreement you have with your dealers or distributors, you might define that. In our case, we'll keep it as first day. Okay. So what else is there? So there are three options: periodic demand with first occurrence. So you can define which day. So rather than first day of the month, first March, you can say that okay, demand will start from 5th March or 6th March. At what time the first order will come to you, right? So that is where. So this is how these two are different. Periodic demand, you have first day as automatically it will take, or you might say that okay, last day or in between any day, randomly it might select. Periodic demand with first occurrence, it gives you an additional option to select first occurrence when actually it is happening, right? Any day you can select, right? Then there is something called historic demand. Let's say I do not have any idea about what will be the forecast demand. I have not calculated. Last class I had asked you to do some forecasting, right? So let's say you have not done that exercise. You do not have any idea about what is the forecasted demand. So in that case, what you can do, if I select historic demand, I can go here and randomly, not randomly, uh, that is incorrect. Whatever has happened in my past 6 months or 1 year, whatever demand, let's say particular day. So I'll start adding. So let's say in January 1st, there was a order of 10 units. Then, so January, let's say 7th, there was an order of 5 units. Like that, if I can put my historic demand, right, automatically it will estimate your forecast demand for you, right? So here what is happening, you do not have the data of the actual or forecasted demand. What you have is historical demand from that customer, that distributor, or that dealer, and that's what you are entering, right? And accordingly it will decide what will the forecasted demand, right? Any questions on the demand type? What is the difference between periodic demand with fast occurrence, and historic demand? So in our case, we'll start with the periodic demand. Okay. Then first occurrence, I'm taking that on the first day of the March 1st, right? The first order will happen. Now what happens? Order interval days, this I had selected as 7. That means every week there is a order. Then how much quantity, right? So this I can define whatever the forecasted demand from that customer or distributor or dealer, that I can define 10, 15, 20, whatever the number of units, right? So this is something which is a fixed or deterministic demand, right? There is an option to change that also, right? Not necessarily every month or every week there is a uniform or a equal demand. I can put it as a probability distribution. So order interval might be changed. So it is not necessarily that every week there is order. It might vary from some day it is within 3 days. Again, the distributor is ordering. Maybe after 15 days it is ordering, right? Not necessarily every 7 days there is order. So rather than putting a value, I can put a distribution for the inter order interval days when the order is coming. It can be uniform, triangular, exponential, normal, log normal, gamma, right? So different type of distribution is available for me to define the order interval days. Again, we'll start with a very simple one. We'll put value only. Similarly, I can change the quantity also. Quantity, rather than having a fixed value, I can have a probability distribution, right? So in that case, what happens? You are not restricted by the deterministic value of the whatever the demand frequency and the demand quantity, right? I can change that, or I can give options to change that also, right? So this is the order interval days and quantity. Okay. So this, if you see in the other case, in the Delhi case, it has taken 10, 9, 27, 986, right? How did it get that number? You remember we had defined one customer per population density, right? So from that, depending upon the population density of Delhi, it has multiplied by the weekly demand, and accordingly it has got that number. So that's why if you see for each of those customers, it has got different type of quantity. In our case, what we'll say, we'll make it very small. Let's say 20. Again, this is because we are just doing a small exercise just to show you how it works. Okay, so randomly I'm just put some number just to show you, right? Then time period. So we just want to understand it for those 3 months. Okay. So customers were defined automatically. Then demand, I defined product, period, and demand. Right. So I have 10 distributors, dealers this way. What I'm trying to find out through greenfield analysis is where I should put my warehouses, right? So here, if you click it, so it will show that okay, whether your data is correct or not. If there is certain issues with your data, right, it will show a error, and by reading that error, you can know that where actually you have done a mistake. So now I'll click on the GFA experiment. So number of site, how many sites warehouses I want, right? We'll start with one, right? Uh, Distance tape for statistics, right? So it will look into that 100 kilometer Okay, first let me change the product measurement unit, right? So I had taken as number of pieces, number of packets of organic drinks. Distance measuring unit is kilometer. So it will look into 100 kilometer gap and try to find out. So within a range of 100 kilometers, right? So that means what happens, your kind of whenever that simulation runs, it will run in a step of 100 kilometers, right? Not less than that, right? So if you want to make it very little bit kind of longer distance, I can make it 200 or 300 depending upon my requirement. What else? Nothing else I require to run the my first GFA experiment. Once you have defined, only thing what you have to remember is remember whatever product measurement unit what you have defined here, it has to be same here, right? So if you see, out of 10 locations, my warehouses has been based on the distance, right? Because I have not defined the transportation cost, right? How much it costs to transport. So that cost I have not defined. So where actually on what basis it is calculating that which should be the my warehouse location? It is calculating the total distance multiplied by the number of product requirement, right? So that it is trying to minimize, right? Distance multiplied by the requirement of weekly product, right? From those locations. And it is defining that, okay, my warehouse should be in this location. If I go here, where is my result? Okay. So this greenfield analysis distribution center has a latitude of 20.69, longitude of 74.312. Where does it actually is coming? Near Malegaon, right? So if I have a hypothetical customer distribution in those 10 locations, right? With those order what I have defined, my distribution center should be ideally here, right? In nearby Malegaon, right? Then it will show that, okay, which how much demand percentage is happening, right? From each location, demand coverage by distance, right? Because I have just put a one location, right? It is not telling that all the locations are being served by that distribution center, right? What I'll do, I'll go back to GFA experiment. I'll change the number of sites to 2. Now rather than having one warehouse, so let me check that if I have to put 2 warehouses, right? Where should those 2 warehouses should be? So if I come back and see it results 2, so it is near to some place in Surat, Sion, right? And the other location is in the southern part. See, like when I change my option from one location to 2 locations, I can have 2 warehouses, right? The other locations is nearby Chennai, right? Now if I go and see that, okay, where I have 2 locations right now, and it will show that, okay, which customer, where is that product flows? Okay, which customer is served by which distribution center, right? So the first distribution center, GFADC, that is in nearby Surat, is kind of catering to Kanpur, Surat, Mumbai, Pune, Ahmedabad, and Delhi customers. The other distribution center, GFADC2, is catering to Chennai, Hyderabad, Bengaluru, Kolkata customers. Right. So these give me an overall picture of where I should put my without again. So there are a lot of complexities which will try to build in. Right. I have not kind of included many complexities like transportation cost, transportation route, different products, then different frequency of order, different kind of quantity of order, right? So those are the complexities we'll gradually add. But to start with, this is a very simple exercise to find out our distribution center, right? Amok, did you do it? I don't know whether anybody else have downloaded and started using the software.
Yes, sir. The output is showing on the screen.
Okay. Okay. So like I said, the first step what we did is basically when we do not know about the customer, right? I just randomly 10 customers decided by the software. But most of the cases, at least we'll have idea that, okay, these are our customer locations, right? So how to do that, right? So we'll start with a new scenario. Which basically will be utilized when you do your exercise. You have to carry out the same kind of steps. So in this case, what I'm doing, I'm not adding scenario data, right? So the scenario data I'll customize on my own. So I'm not asking the customers to randomly or hypothetically select 10 or 5 customers. That I'm going to define on my own. So I'll not click on this add scenario data, right? I'll just put class work to 24th February. Same thing we'll do, but we'll define our customer location, right, on our own. First merge to 1st June. Okay. So let me do it for very, like I'll take a few location in Odisha itself. Let's say the same example what I was doing. Right. Let's say I'm a small startup, milk startup, and I have started my business. I'll choose 4 or 5 locations, right? So in that case, what happens? I'm not asking customers to, sorry, I'm not letting software to choose customers based on the population density, right? I am defining my customers because that knowledge I have. I have done certain survey. I know which are my major customer centers, right? So, so what I'll do here, I'll define my customers first. To define my customers, so there are 4 options: create customer, create warehouse, create factory, create supplier, right? So in today only we are going to discuss on defining customers and finding a warehouse. Later on when we get into the network optimization, we'll define our warehouses and factory. Then again make it little bit complex and put suppliers also, right? So now what will happen, we'll just define our customers. Click here, let's say double click. So Raukla is one, Sambalpur is one, Bhubaneswar is another. Okay, just let me write the names otherwise. Bhubaneswar in southern part, I'll take city. So one kind of observation or kind of which is already exist in this software. If you see, this is a economic version, right, which is free to use. So there are a lot of things which is not available, right? Because when I'm selecting these customers, right, though the map is being shown, but which is the exact location, I might be selecting a top of the hill or in the river or wherever actually not the location is there, right? But in the commercial version it will show along with the road, so you can actually define whatever the actually your warehouse location or the customer location where exactly your distributor is there. So it is integrated with your Google map. But here in this case, though it is extracting the map, right, it is not as detailed as in our commercial version, right? But at least for learning, we can use and make a accurate estimate, right? So what I have done, I have defined my 5 customers, right? So these are my 5 locations. Then product, let's say this is some handicraft item. Or let's say this is okay. For now, we can keep that, right? Handicraft pieces. Okay. Period is already defined, so that I need not change. Now the demand, right? If you go for those 5 locations, I have to define my demand, right? So remember the steps for your class exercise also, same thing you have to do. So there, what I've done, I have, or let me take that same example. Let's say electric vehicles, right? So let's say I have 4 product, EV20. So in your class exercise, actually I have given you 4 metro cities: Mumbai, Delhi, Chennai, Kolkata. Here I am taking 5 of my. So let's say it is for the electric scooter vehicles. These are my 5 major locations where demand is coming, right? So I have 5 customers and 4 different products, right? So how many demand will be generated? How many like kind of options for demand? Potential options for demand. If I have 5 locations or 5 customer locations and 4 different products, how many possible options of demand is there?
So 20 options.
Correct. So because potentially all those locations can sell those 4 products unless I put a constraint. No, from this location only demand for this product will come, right? Potentially I should have 5 into 4, 20 demand points, right? So actually in that case, what I should do, I should add, so my, so like that, if you see the class exercise which I'll give it today, so you have to add, so for Rahul Killa, I have taken 20, 40, 60, 80, or 4 rather than Sambalpur. So this is again manually little difficult. I'll show you how to kind of actually next class, uh, rather than typing manually or clicking manually, how to do it little bit smarter way. Sorry, not. So all class done. Sambalpur, Bhubaneswar, Baripada. All class, Bhubaneswar, Baripada. Again, repeating demand for all those 5 locations, 5 distributor locations. What I am defining is for different products. So I have 4 different products, E20. So 4 different type of electric scooters. I am defining their demand requirements. Right. Okay. So again, periodic demand, order interval 5, quantity 10. So I can make some changes here for different product, different demand, right? So let me make some changes. Okay, not necessarily you have to do it for all the kind of locations. Okay, so I have now 20. So how it was constructed, I have 5 locations and there are 4 product options. Potentially I have 5 into 4, 20 demand options, right? So those things I have defined. Like I said, I have 3 different types of demand options. Either I can define periodic demand with fast occurrence, or historic demand. Historic demand when you do not have a forecast, but you have historical data. You just put that historical data and accordingly software will calculate forecast for you, right? In our case, we have a like assumably we have the forecasted demand and that's what we are including, right? And also our order interval days, okay, let me make it 7 per each handle. So for each of the locations and for each of the products, I'm defining that weekly there will be demand for certain quantity. Okay. So once I do that, okay, another 5. So once I define that I have 20 demand options, again I'll go and check that my data is correct. If there is error, it will show here. Then I'll run a GFA experiment. So first I'll start with if I have to put one site, make sure that product measurement because I have taken this number of pieces, number of unit. Okay. And if I run it, so if I have these 5 locations, so near Talcher, the location is coming, my distribution center or my warehouse, main warehouse should be near Talcher, right? Because like I said, because this we are using academic version, exact location along with the roads is not available, which is available in a commercial usage, right? Because we are using a non-commercial use version. With roads experiment, if you see, GFO with roads experiment is not highlighted for us. We cannot use that, right? Same thing I can again run if I just want to build 2 warehouses, right? Where should those places should be? So now if you see, rather than near being near Talcher, so the 2 warehouses, I think one is near Bhubaneswar, the other is near Raurkela, right? So same thing, wherever my 2 major customer locations are there, it is choosing those 2 as my having my warehouses nearby them, right? To cater to all those 5 customers, right? Then the thing is how it is calculating, how it is minimizing. So what actually it is minimizing the flow distance, right? Number of products required from each location multiplied by the distance, right? That it is taking as a cost and it is trying to minimize that. Because see, we have not defined any transportation cost yet, right? In the next scenario, we'll add the transportation cost and try to see that okay, when we put transportation cost, which will be the locations, right? Because transportation cost might vary from one location to other, the distance might vary accordingly. Transportation cost depending upon which kind of vehicle also you are using. If I say from distribution center A to customer B, it will be used one type of vehicle, right? Then the and from distribution center A to customer C, another type of transportation vehicle, right? In both the cases, there will be difference of transportation cost, and accordingly, your overall cost parameter will change, which will might change your location also, right? But we'll, like I said, we'll start with a very simple one and try to find out which is our ideal warehouse location. So this is a greenfield analysis. Why it is greenfield? Because we are starting our warehouse from scratch. We do not have an existing warehouse. We are trying to find out if I have to put one warehouse and I have these 5 customer or distributor location, where ideally I should put my warehouse, or if I have to put 2 warehouses, where I should build those 2 warehouses. Any questions or any doubt on this? Okay, so like I said, there are two. I have shown you 2 ways. One way, when you do not know the customer locations, right? You ask the software or this tool to kind of generate customer locations based on the population density. That is one way. Two-way, graphically you can select the customer locations. Then there is another way. So what you have to do, go to this data. So if you right click on this, right, export scenario to Excel file, put OK. Okay. So I'll just open that Excel file. So if I open that Excel file, all the information is available in this Excel file. So like I said, rather than manually typing all the details here, right, I can just type few data, right, and all those things in Excel, I can copy paste from wherever my other data is available. Let's say location wise, demand, forecasted demand is available in another Excel file. So I can just copy and paste it here, right? Not necessarily everything I have to manually type or click on that software, right? So here if you see locations, latitude, longitude, because I have selected in the software in that user interface, it is showing latitude, longitude here. Let's say I do not click there, but I know exact location, latitude, longitude of those places, right? What I can just do it here, I can put the location name and I can mention the latitude, longitude, right? So that is the third way to define your customers. So the first way is let the software uh, automatically select customers based on population density. Second way is to go to the user interface, select customer based on the location. Third is to export the scenario, this Excel file, and put the latitude, longitude, right? And once you upload that, so there is a option to import data. I'll show you once I discussion of this is over. So you can import data and kind of upload information there also, right? So these are the 3 ways to define a greenfield or kind of create a greenfield analysis scenario. So here the advantage is not everything you have to kind of type or click or input in the software itself. You can download the Excel file. You can change, you can add product, you can experiment any of that tutorial on its own. But the input variables, right? Products, periods, locations, demand, all these options here. If I say whatever numbers I have put, right, here I can put in, let's say, let me change few things. So let's say rather than 100, I'll put 23, 55, 54, 21, 55, 57. Okay, so I'll save it. Okay, I'll save it in other name. So now what I'll do, I have made some changes in the data. I'll go and use the new data, right? So here if you see, there is an option of import scenario from Excel. If you go there and see the changes what I had made in the Excel file 23, 45, 54, 21. So these are the few changes I had made, changes in the demand, right? Now I had imported the data, right? It is little bit easy to copy paste in the Excel, right? If I have the information of the demand, so I can for 100 locations or 100 customers, different 5,000 rows also, right? I can, if the demand options are there, I can just copy from some other file and paste it there, right? Then upload it, then make sure that the data is correct. If I want to put two locations and run the simulation, still it is coming, but right now if you see, okay, no, location remains still set, right? Because demand, again, I did not make it that significant change, right? But this is how you can create different scenarios, right? If you know the customer or distributor locations and you want to find out your warehouses. It can happen in other way around also. I can have locations of my warehouses and I want to build my new, let's say, manufacturing plant or production plant. That also can be done in this way, right? I'll first define my warehouses, distribution center, and now I have to define my production plant, right? So that will add some little bit complexity. Then if I include certain suppliers, now I have to also look into the constraint of suppliers, right? The distance of supplier sending the raw material to my plant and my plant or the production plant manufacturing those items. Then it is going to the distribution center and from distribution center to the customers, right? So it will build to actual supply chain complexity, right? Think about a FMCG product company, right? So they have to look into everything where their major distributors, dealers, warehouses, where their suppliers are there, and accordingly they have to define that where they need to build their a new plant or new manufacturing infrastructure, right? So these are the like starting of your simulation. Today what we discussed is known as greenfield analysis. Any questions, any doubt? I have given you exercise, same thing what I just discussed, but rather than locations being or within Odisha, those are four locations, four metro cities, and four different product types, EP20, so four different electric scooters, and weekly demand for each location I have defined, right? So same scenario you have to build in a this software, using this software, run the experiment, run the greenfield analysis, and whatever results I have asked 4 or 5 questions. Once you run the experiment, those answers. So what will the latitude, longitude of the new location? What is the total distance covered, right? So if you see, this is the distance calculated flow cost, right? So how this flow cost is being calculated? Number of pieces. So this is the total number of requirement of EVT from that Bhubaneswar location, right? Within that the time frame which was given, right? Distance on kilometer, right? Then the total cost will be 140 multiplied by 0.154, right? So let's say I take another GFA that is near Bhubaneswar to Barampur. Same number of pieces, 140 requirement. Distance is 151 kilometer, right? 151.989 kilometer multiplied by 140. So that gives you this total flow cost. So remember what I said, flow cost, how it is defining? Number of product requirement multiplied by the distance, right? Additional complexity, what will be the, because here it is taking distance as a parameter which we are minimizing, distance multiplied by number of product. Actually what should happen, what is the cost for covering that distance, right? Because if I use different type of transportation vehicle, I'll be interested how to reduce the cost of traveling, cost of transportation, right? Right now, because I have not inputted, I have not included the data of transportation cost, it is only taking distance from one place to other multiplied by the number of product, and it is trying to minimize that. right? So what else? So if I just do it, so I know that, okay, GFA DC is going to 8 customers, like catering to 8 customer centers, and GFA DC2, which is near this. So which one is GFA DC? So this is custom. So GFA DC2 is near Ramkala, right? Wherever your customers is. That is catering to 12 customer locations, right? So what is the total flow cost? Sum of total products being handled is 3598 from GFA DC, which is in Bhubaneswar, around 1890. So if you see GFA DC2 is a bigger warehouse, right? You need to build a bigger infrastructure. Total cost is 337,265.9, right? If I just assume that, okay, per kilometer cost of transportation is 1 rupee, right? So this is the total cost which will incur to have our GFDC2 in Rourkela and send material to all those 12 customer locations. And from GFDC, which is catering to 8 customers, what is the total cost? 108,700,587. Here you can assume that, okay, per kilometer cost is 1 rupee, which because we have not added any transportation cost, transportation vehicle, which will add later on, right? So this gives you idea that, okay, which distribution center catering to which kind of customers, which kind of product, and what will be the total cost of transportation, right? Because here only the cost which you are looking into is the transportation cost or the transportation effort actually, right? Not cost, because you have not put a cost parameter. Okay. Hope this is clear. If some of you have not downloaded the software, please download it. This is a very interesting software. Without writing any code, any kind of mathematical equations, you can do a lot of things, right? Only running this kind of simulation or experiments. If there are no questions, I'll stop for today.
Sir, I missed my attendance.
Okay.
Will you share the recording?
Yeah, I'll do that.
Okay, thank you, sir.